Hi, today I'm going to talk about the exploration of 3D visualization for system optimization. This is my top topic for the project. Um, First of all, I will talk about my thoughts about the project. Then I will talk about the iterative algorithm. I will visualize this algorithm, and then I will visualize each iteration and keep track of the checking the iteration, how it progress in the function. And then I will talk about the quit hop and the implementation of the quit hop algorithm. Uh, and then I will talk about the challenges for this project. Finally, I will reach a conclusion. My original thought about the project, my original ultimate goal is think about how to visualize high dimensional data, which is Rn and high dimensional function, like functions on Rn to Rn. And then I find a paper, it shows this type of graph to uh, visualize high dimensional data. And this graph of also take advantage of the color as dimensions. um, I've, I think it's not very intuitive because if you want to locate specific color, you have to search the whole graph. But in the typical graph visualization, you can locate a data easily by looking at the y-axis, x-axis, etc., something like that. So I think this type of graph are not intuitive and needs time to learn and understand. So I begin with a project with three-dimensional data, and and I know of theory that the screen is two-dimensional, uh, but human can interpret it easily to three dimensions because we had the knowledge of the three-dimensional worlds. Um, and then I will find some property of the high-dimensional data. Some property of high-dimensional data are very basic, like the convexity. I think it's a way to organize the high-dimensional data. Let's talk about the tool and basic concept. The tool I will use OpenGL and C++. OpenGL is the famous old 3D graphic API. And C++ is a programming language. And I will also use the linear algebra and geometry computation as this knowledge to for my project. And next I will visualize the iteration of minimized function on two-dimensional to one dimension. And then I will talk about the quick hop algorithm. Um, this algorithm is the step-based gradient descent. It's a textbook algorithm. It's what we learn in class, and it uses big backtracking line search. You can see the step, and the function is this one. I have to visualize it, like visualize the function around the origin and the minimum. You can see the step length if is is large and is kind of optional. It's kind of optimal, and the direction is close to optimal, and step is large, and then it converges very fast. Then this one is the stochastic gradient descent algorithm. It's popular algorithm in machine learning. It's a simple algorithm. It randomly chooses a dimension to minimize. The step length is the derivative of the is derivative of the cost function times the times a constant. I build like this function, and you can see the step length is it's not very large, and pretty much constant, because the derivative is like the derivative is the not very large, and it's a simple algorithm, but it converges not very fast. This one is simulating annealing. Visualize this function. It has multiple local minima. The advantage of simulating annealing is it can minimize function with multiple local minima. It uses random direction and random steps. It also has a acceptance function and a temperature function. The temperature function is a probability whether it accepts a worse solution or go to the better solution. A worse solution doesn't mean it is worse, but because there may be a lower minima, lower local minima. But the disadvantage of this algorithm is you don't know where to terminate this algorithm. It may take infinite time, and this is like most of part is random, so it may take a long time, and it's also very difficult to determine the scaling. It's difficult to choose the initial temperature and the temperature, how the temperature cool down, and how to choose the acceptance function. But it's a popular function in VLSI placement. I have used several examples for minimizing a function on 2 dimension and to 1 dimension. For visualize the function, I use the sampling, and then interplay with triangle and then the OpenGL can use the triangle to interpret it. I thought this type of visualization are useful to design algorithm, and you can visualize the some part of algorithm. But when the functions are very complex, you only can visualize part of it, and it's not very useful. And I will talk about QHOP function. Firstly, I will talk about the overall algorithm, and then talk about the key implementations. The QHOP algorithm. This is the pseudocode, and a face is a triangle formed by 3 points. Let me go through this algorithm. And at the beginning, it will use some extreme points to create a initial hub, convex hub, and then use the faces of the convex hub to determine the outside set.